I was completely blown away by the response to my last video. Thank you all so much. In that video, I mentioned a tool that saved me, both in game development and throughout my engineering career. Git. In this video, we're going to set up a GitHub repository, connect it to a Godot project, start setting up the main game scene, and walk through the workflow I use when adding new gameplay systems. And lastly, we're going to add Git to an existing Godot project. This isn't going to be a complete beginner's guide, but I'll cover the basics quickly, and I've put together a few extra resources. So no matter your experience level, there should be something here for you. So let's get started. Before we jump into the workflow, let's quickly cover what Git actually is. Git is a version control system, which means it tracks changes to files over time. The easiest way to think about it is like a checkpoint system for your project. As you work on your project, you can commit changes when something works, and if you break something later, you can always revert back to that earlier committed state. A common thing I see when people are first being introduced is confusing Git with GitHub. They are not the same thing. Git is the tool that runs on your computer and tracks changes to files. GitHub is simply a way to remotely host these Git repositories so that they can be backed up and shared with others. Git can run entirely on its own without GitHub. If you're on Windows, I recommend installing Git for Windows and using Git Bash. I also recommend using the command line because I find the GUI tools tends to cause more confusion than they solve. Once installed, any folder can be turned into a Git repository. We can create a folder on the desktop and navigate to it in Git Bash, then run the command git init. And congratulations, we just turned that folder into a Git repository. Yay! Git is now watching this folder and tracking changes to the files inside of it. If I add a file, Git can see it when I run git status. But it hasn't been included in a commit yet. To include it, I stage the file using git add-a. This tells Git which changes I want included in the next commit. The -a stands for everything. Then, using the git commit command officially makes this commit part of the project history. In other words, it creates a checkpoint. The -m here means that the text following it will be the message associated with the commit. And we can see that it now appears in the project history. One last important concept is branches. Branches allow you to create what you can think of as a separate timeline of commits, so you can experiment and build new features while keeping your main branch in a working state. You can create a branch with the command git checkout-b, followed by the name you want for the branch. Now, any commits I make will exist only in this branch instead of the main branch. If everything works, I can merge those changes back into the main later. Branches also provide the easiest way to revert to a working state. If you're working on a branch and something breaks, you can always check out main and go back to where you started. And that's a basic idea of Git. Now let's take a look at how I actually use it when starting a new Godot project. If you're looking to add Git to a pre-existing project, we're going to use everything we learned here to do that at the end. I'm going to start by creating a new repository on GitHub. It can be done the other way around, but I prefer using this workflow. After logging into GitHub, I create a new repository, give it a name, optionally add a description, have fun with it if you're going to keep it private, which you'll most likely want to do, but you have the option right here. Next, we come to a very important file, the .gitignore. The gitignore file tells Git which files it should not track. This keeps things like exported builds, backup folders, and local configuration files from cluttering up the repository. GitHub actually provides a drop-down template specifically for Godot, which is a great starting point. For my project, I usually add a few additional things like my exported build folder, my editor configuration folders, and local backup directories. Once the repository is created, I clone it to my local machine. I use SSH authentication, so I don't have to type my password every time. I copy the repository URL and run git clone and paste the URL in. This creates a local copy of the repository on my computer. We're essentially at the point where we created the project locally, but now it's linked with the GitHub. Yay! At this point in my workflow, I like to immediately create a branch for setting up the new project. Git checkout-b initial project setup. I also push this branch so that it will exist remotely on GitHub. Now I open up Godot and create a new project, making sure that it's inside the repository folder. Godot even has a handy dropdown to enable Git version control directly when creating the project. Once the project is created and I've configured my project settings, I go back to the terminal and check the repository status. Then I stage everything, git add-a. Before committing, I always double check the file list to make sure that my gitignore is working correctly. Once everything looks correct, I commit my project and push it to GitHub. From there, I open up a pull request to merge the initial project setup branch into main. We're going to go into detail on pull requests a little bit later, so don't worry about it too much right now. Bottom line, our initial project setup changes are on the main branch in GitHub. And by the way, I'm going to add a link to this repository in the description if you're interested in checking it out. Now, we just need to get the changes from GitHub back onto our machine. We do that by checking out the master branch and using the command git pull origin master. Once all that is done, we now have a clean Godot project under version control and ready to build on. At this point in a brand new project, one of the first things I usually set up is the main game manager. One of the compounding factors that ended up killing my first project was the lack of a strong foundation early on. So this is the structure I use now going forward. At the top is the main game scene, which is the scene configured to run when the project starts. This scene is responsible for setting up the core layers of the game world. The level layer is where the levels are loaded, the entity layer is where dynamic objects like players and enemies are spawned. It also initializes the high-level systems in the game. In this example, the spawn manager. Finally, we have a HUD layer for UI elements and a pause layer for the pause menu. In my next couple of videos, I plan on going more in depth into this setup, as well as walking through adding a full gameplay system into a larger project, starting with the spawner system I mentioned in the last video. Let me know in the comments which you'd like to see covered first. That initial setup is just the beginning. Let's walk through a bit of my day-to-day workflow. We're starting from a point where everything we just did is merged into main. For this example, I'm going to be adding an animated sprite based on a creature my daughter created. She calls this one an indoor. General best practice is to create a new branch whenever you start working on a feature. I start on my main branch and create a new branch. Git checkout-b followed by the branch name. Then I push the branch, specifying origin and branch name. Origin is the name of the remote, basically our connection to GitHub, and the branch name tells GitHub where to push, creating it if it doesn't already exist, like in this case. At this point, I work on the feature and commit when necessary. When is it necessary? Well, that depends. Sometimes it's the end of the day and I check in a work in progress. Sometimes I know I'm about to try something crazy and make a commit before I break anything. And sometimes I finally get something working and immediately commit before touching anything else. But for this one, throwing in an animated sprite should be pretty easy. Now that the feature is complete, we add, commit, and push, and we're ready to hop into GitHub to merge into main. The merge can be done directly through Git, but most teams prefer using GitHub pull requests. The pull request allows the changes to be reviewed before they're merged. And if changes need to be made during the pull request, you simply update the code, commit again, push the changes, and the pull request automatically updates. Once everything looks good, the branch can be merged back into main. At this point, I usually squash and merge, which mushes all those small development commits into a single clean commit on the main branch. This keeps the main branch nice and clean by combining all those work in progress messages with one clean commit message. Just like the initial setup, we want to sync with the changes we just made on GitHub. Git checkout master and git pull origin master. And when we're ready to start a new feature, just create a new branch. Git checkout-b with a new branch name. And that covers all the basics. But there's one more tool that's especially useful in game development. Game projects tend to include a lot of textures, audio files, videos, and other large assets. And Git handles those very differently than it handles code. This is where Git LFS comes in, which stands for large file storage. When a file is tracked with Git LFS, Git replaces the file in the repository with a small pointer file, while the actual asset is stored separately in LFS storage. One thing to keep in mind when cloning a repository that uses LFS is that you may need to run git LFS pull to download these large files locally. As far as I know, Git LFS does not come pre-installed with Git for Windows, so you may need to download it from gitlfs.com, and then on the command line run git LFS install. But you'll only need to do this once on your system, not per repository. But you will need to tell each repository which types of files should use LFS. And you can do that with this command, git LFS track with the file type. Or by directly editing the .gitattributes file, which I'll cover in a moment. It's a pretty good idea to add the usuals right away, files like .png, .wave, .ogg, .mp4, and anything else you know you'll be using in your project. But the easiest way to set this up is by editing the git attributes file. You'll find it at the root of your repo, the same location as the gitignore. If it doesn't exist, you can add it. On screen right now is the attributes file that I use, which originally came directly from the Godot documentation. Follow the link in the description to the repo we created, and you can copy this file yourself. And now it's time to add Git to an existing Godot project. The steps for this are going to be very similar to what we've already covered. Like earlier, there are multiple ways of doing it, but this is the way that I find the easiest. Follow the steps as earlier for creating a new GitHub repository and cloning it onto your machine. Use the command git clone followed by the URL. Create a branch for introducing your project, git checkout-b with the branch name. Before you do anything else, make sure your gitignore and LFS is correctly set up. Remember, you can copy both files from my repo, and that should be sufficient. I usually make a commit at this point, but it's not required. Open your project and select Project, Version Control, Create, Override, Version Control Metadata. Make sure Git is selected in the dropdown and hit OK. Then just copy your Godot project directly into the Git folder. And all that's left to do is add all, create a commit, and push it into GitHub. Then on GitHub, create a pull request and merge it into main. Now you're good to go. Just don't forget to branch and commit so you'll actually have checkpoints to go back to. Before we wrap up, I put together a Git cheat sheet with the commands we covered along with a few other helpful tips. If you'd like a copy, you can download it from the GitHub repository linked in the description. Let's quickly run through the commands you'll use most often and a few critical tips you need to know. Check where you are with Git status. Add your changes, commit your work, push to GitHub. Pull the latest changes. Switch branches. Create a new branch and switch to it. You cannot switch branches with active changes. You have to either commit, reset, or otherwise remove them first. View all your previous commits with git log. Git bash starts in your home folder, usually C user's username. You can type echo home to print this path in the terminal. Inside git bash, Control-C and Control-V are not copy and paste. Control-C cancels commands. Use right-click to copy and paste. And if, well, when your terminal gets stuck, Control-C gets you out. If things seem out of sync, run git fetch-p to help clean up stale remote branch references. And the most important, git good. No, really. Everyone struggles with Git at first, but once it clicks, it becomes one of the most powerful tools in your arsenal. You've got this. From the bottom of my heart, thank you so much for the overwhelmingly positive response from the last video. Every one of you has been absolutely amazing, and I am incredibly grateful to be interacting with such a great community. I hope I can continue to provide the useful information that you all deserve. Thank you so much for watching, and I'll see you next time.